Okay, here is the last part of lecture 1. We're going to continue with our discussion of nomenclature here. All right, so now we're going to take the chemical name and transform that to a chemical formula. So it's important that we're able to do the first, going from formula to name, then name to formula. So calcium sulfide. So here I find it helpful if you write the name of the element and the charge. Or sorry, write the formula for the element. So calcium is in group 2, 2 plus. Sulfide is sulfur, and that's in oxygen's group, so 2 minus, group 6. Okay. So since the charges are the same here, and they're opposite, we don't need to add any subscripts to any of the elements in the formula, so we take calcium and sulfur, CaS, calcium sulfide. All right, on to the next one, nickel 2 acetate. So acetate comes from acetic acid, a very common chemical in the household for cooking and cleaning. So nickel 2, parentheses 2, means we have a nickel atom, Ni, and the charge is 2 plus. Okay, so every Roman numeral will always be associated with a metal and a positive charge. So acetate, that's given in parentheses. Please just memorize this formula, C2H3O2. Oops, let me fix this. Okay, so since this formula here, the charges are now not the same. They're not of the same magnitude, so we will have to use subscripts. So there's 2 ways to do this. You can use some mental math if you're very good with addition, multiplication, and adding, subtracting, or you could use the crisscross rule where you crisscross the charge to the other element or the other ion, and that will give you the right ratio that you need to put in the subscripts for the chemical formula. So we can put a crisscross rule here, and then another crisscross rule here. Okay? So that means our nickel will have a 1 subscript, so we don't need to put anything there. But our acetate now will have a 2 subscript, so we need to put that in parentheses. C2H3O2. Don't put any charges when writing the chemical formula. Those they make a neutral compound, so we don't need to do that. So see here, we put the 2 there because since acetate has a -1 charge, we need 2 of them to have -2 charge to pair up and negate the 2 plus charge on nickel, so we have a neutral compound. So all these compounds are neutral. Okay, potassium cyanide, very toxic compound. Potassium is the symbol K, and the symbol K has a +1 charge, same group as sodium. And then cyanide is a polyatomic ion, so you'll just have to know this, memorize this formula, Cn-. Okay, since the charges are the same magnitude, we can just combine the elements here and write KCN. All right. Now let's use sodium bromate. So bromate comes from bromic acid. So it's another polyatomic ion, and you'll have to kind of know the differences between bromate and some of the other related polyatomic ions. So I'll write them here. There's BrO minus, or bro, BrO2 minus, BrO3 minus, which is what bromate is. So this is hypobromite. This is bromite. This is bromate. And then lastly, BrO4. This is perbromate. Okay, but let me just move this over here so it's not going off the page. So BrO4 minus is bromate, perbromate, sorry. So you see here there are different names depending on how many oxygen atoms are there. So for bromate, it's BrO3 minus. So sodium, Na+, same group as potassium. Bromate is a polyatomic ion, so you just have to know this one, BrO3 minus. And the best way to kind of remember these, I had a hard time too learning these as well, is to simply look at them over and over again. Repetition, you know, studying requires sometimes to use repetition, flashcards. Unfortunately, this is one of those concepts you have to use memorization as the best tools to learn it. So bromate, sodium bromate, they have the same charge. So we're going to write, sorry, not the same charge, but they have the same magnitude, but opposite charges. So sodium, BrO3. So you just combine it like that. Okay, aluminum hydroxide. Aluminum is from group 3, so Al3+. And hydroxide is another very important polyatomic ion, a very strong base. It is OH minus. So just like with the nickel example, we have to use some subscripts here when writing a chemical formula. So if we use the crisscross rule here, we get Al, then in parentheses OH, close parentheses, 3, because when we use 3 hydroxide ions, that gives us a total of 3 minus. That will chemically, electrically neutral the compound, because aluminum is 3+. So it'll negate the 3+ from aluminum, and here you have a ionic compound, aluminum hydroxide. Okay, so that's aluminum hydroxide. So that's naming ionic compounds, writing the formula. In the workshop, we will do more practice with this. Okay. Chapter 3, molecules. So now, this is the last of this lecture. So we've been talking so far about molecules, compounds, and just naming them generally. We'll talk chemical equations in the next lecture. Okay, molecular compounds. To name molecular compounds, we take the first element and the second element, and we use prefix to indicate the number. Indicate the number of each element in the compound. The ending is named similarly, like ionic compounds. We add IDE for the second element, or just for the second, for the second element or second polyatomic ion, etc. So in this case, we use molecular compounds. We use prefixes. Okay, and I forgot to erase it. All right, but let's just pretend we didn't see that, so we can go over it again. My apologies. Okay. So those names were up there, but maybe you don't know how to get those names. We're going to go over that right now. The reason they were up there, I pre-recorded it, but Zoom didn't save my recording for some reason, even though I hit record. So that's kind of a bummer. So I have to redo it. But here we are. So boron. So you don't typically have to put the prefix mono for the first element, because if you don't put a subscript, it's automatically assumed that it's one atom in the chemical formula. So for example, we would do boron. And then fluorine has 3 atoms in the formula, so we put tri in front of the second name here. So trifluoride. So we take off the fluorine, INE, add fluoride. Okay. Here we have silicon. So again, you don't need to put the mono here. Silicon, tetra for 4. chloride. Okay. Xenon F6, Xe F6 is xenon. Xenon, a noble gas. Xenon hexafluoride. So xenon hexafluoride. So it looks pretty straightforward. Naming, people can get confused on naming, so it's important that you do practice of both these types of compounds and ionic compounds, and mentally distinguish them or kind of compartmentalize how to name each of them, because the naming does sound similar for both. All right, the last example is N2O5. So dinitrogen almost said it. N2O5. So this one does have a prefix for nitrogen. So we say dinitrogen. Then you would think it'll be pentaoxide, but it's actually not pentaoxide. We abbreviate it to say pentoxide. And I don't know why it's not pentaoxide. I think it's just naming convention. We just decided to drop it for just this one. I don't know why, but it's just known, like, historically speaking, that it's pentoxide and not pentaoxide. Maybe it sounds a little weird because you don't see this for like things with two syllables, right? Penta. You don't see it for pentaiodide. It's pentaiodine and not pentidide. I guess it would sound weirder if you dropped it like that. So maybe it just sounds better saying it this way. But pentaoxide, I don't have a problem with it. But just historically speaking, we dropped the A and just put pentoxide. And for things like this, it just takes, it's just things you probably just have to know just by remembering. So yeah, that's nomenclature. That's a brief overview of nomenclature. Hopefully it was not too bad. But that'll be the end of this lecture. So lecture 2 of actual material is now complete. Please do the participation questions. You cannot access the next lecture unless you go through these videos and do the participation questions to keep everyone on track, and so students do not fall behind. So with that, I'll see you next time.